So first of all, thanks, Xiaoyi, for the introduction. And actually, it's my great pleasure and honor to give a talk here at Bench 2021. And my PhD advisor, actually, I graduated last year, and my PhD advisor is Professor Huan Liu from Arizona State University. Today, I'm going to talk about my thesis on understanding disinformation, learning with weak social supervision. So during my PhD study, I actually focusing on developing novel machine learning algorithms to derive supervision from noisy, heterogeneous, and linked social media data. First of all, social media data is usually high-dimensional and noisy. So I developed feature representation learning methods to handle complex social media data. And second, social media usually is very easy to collect social networks with millions of users that provide opportunities for network analysis. So I'm focusing on modeling different types of networks. Third, one goal of studying social media is to understand the social behaviors and provide better service to the users. So I work on different applications to use AI for social problems. So today I will be mainly focusing on disinformation detection with weak social supervision. I want to start with this recent post. Actually, it's not that recent compared to, it's actually a post from last year. This is a post from Forbes about 10 wonderful examples of using AI for good. And spotting fake news has actually attracted a lot of attention in both academia and industry, and is among one of the examples of using AI for social good. Okay. However, fake news is actually not a new problem. Its detrimental effects are amplified by the use of social media. Social media has become a popular means for information sharing, for social networking, and so on. One recent post coming out from the Pew Research Center shows that about 37% of Americans actually get news on social media. So it shows that social media is very important for information sharing nowadays. However, social media is like a double-edged sword. It also enables the widespread of disinformation, including fake news. So first of all, disinformation is commonly referred as the false information with a bad intent to mislead readers. And fake news is one example of disinformation, indicating the news that is intentionally false. Okay, and disinformation is rampant on social media nowadays. For example, study shows that actually this study is one of my co-authored paper with the WHO. Shows that the COVID-19 disinformation has been widely spread and causing called infodemic issue. In addition to that, fake news can be very diverse in terms of topics and domains, such as politics, such as business, such as natural disasters, and so on. So you may ask, why fake news detection is such a challenging problem, right? First of all, it is not like a simple competition. In a typical data mining task, probably it's a binary classification, and then you have a data set, and then you just try different machine learning or data mining algorithm, and then to see which one works best. But fake news detection is more complicated than that in many dimensions. And today, I will mainly focusing on three impervasive challenges, including detection challenge, explainability challenge, and a data challenge, okay? So next, I will introduce three representative research on fake news detection for solving these challenges. First, when we have enough data, okay, of labeled news and social engagements, so the question is, how can we detect fake news effectively with social context? Second, to involve and benefit domain experts such as fact checkers or journalists, how can we make fake news detection results more understandable? Third, social context may be helpful to detect fake news, but it usually takes a long time to aggregate. So we want to understand, can we detect fake news at an early stage, and how early can it be? Okay. So next, I will introduce the first work of leveraging social context for fake news detection, which was published in Wisdom 2019. Since fake news are intentionally written to mislead users by mimicking real news, so it is difficult and to differentiate fake news from real news only by looking at the news content. Okay, so social context during the news dissemination actually provides a lot of useful auxiliary information that can help improve the detection. So to leverage social context, so we aim to answer the two following questions in this paper. First is, what are the actors and their relations in social context? And then how to model the social context to help detect fake news, okay? This is a figure to show you that if in a very typical news ecosystem, usually we have three major entities. The first one is the publishers who publish the news, and the news pieces themselves, and also the users who consume or read the news, right? So there's three major kind of relations among these entities. The first one is the publishing relation between the publishers and the news to indicate who publish what, right? And the second is we call it spreading relations between the news and users. And third one is the social relations among users, such as like in Twitter, you have followers and followees, okay? So these entities and relations that can be represented in this heterogeneous network as shown in this slide. So the goal of this work is really to try to learn the news representation from this heterogeneous network for fake news prediction. So we actually propose a joint modeling approach to embed a news content and social context with this non-negative matrix factorization approach. I will not go through the details, but mainly this approach consists of these following components. The first one is we call the news content embedding. It learns the news representation by factorizing the back-of-word matrix. And the social context embedding actually includes several parts. First one is the user-user embedding, which will try to learn the user social relations and map the relation to the embedding space. And also including user news embedding and publisher news embedding to encode the relations between user news and publisher news. So finally, we have incorporate a semi-supervised linear classifier to map the news representation to the label. Okay, so this is overall our framework. But one challenge is that there's no kind of existing data sets for fake news detection in general that contains both the news contents and the social interactions. So that's why we actually spend a lot of time to curate a very important data set and very unique data set called fake news net. So this fake news net data set actually is kind of comprehensive data repository that contains information including news contents, social context, and spatial temporal information. You can see from this table, comparing to existing data sets on fake news detection, we have a lot of more dimensional information to benefit the research community in this domain. And then and actually this data set is publicly available in GitHub. So I encourage you, you guys, if you're interested in this domain, please check it out. So we have a lot of detailed instruction of the data sets and some code to analyze the data set. So based on this fake news net, we have done this experimental evaluation. We compared this proposed method with several state-of-the-art fake news detection methods. So when we observe that the proposed method consistently achieve best performance on both data sets. When I say both data sets, because in fake news net we have different data sets from different domains such as politics, entertainment. So we have different data sets in the sense. And we also do some ablation study. The ablation study shows that when we consider this publisher news or news user relations, actually these relations are very, very important, and they can contribute the performance improvement of the method. So it indicates the necessary to model both news contents and social context. Okay. To summarize this work, basically we have shown that social context information is very important and can bring additional signals to fake news detection. And it's important to capture the relations among publishers, news, and users to detect fake news, right? And then the proposed framework, TRI-FN, actually is very, very effective in terms of modeling these relations. Okay. So next, we want to ask for domain experts, because fake news is very kind of interdisciplinary topic that are studied by not only computer scientists, but also social scientists, psychologists, and neuroscientists, and so on, right? So we want to ask for these domain experts, how can we build a model that can benefit them by making it more understandable? Okay. So next, I will introduce explainable fake news detection, which is published in KDD 2019. So the goal of this research is really to try to detect fake news, but also explain why it is detected as fake. Okay, but you may ask, like, why we should care about explanation in this scenario, right? Because explanation, first of all, can provide insights and knowledge to those domain experts to help them for their own task, right? And also, if we can extract explainable features, it's also more likely you can improve the fake news detection performance, okay? So since users in social media, they explain their opinions and feedback through comments very frequently. So in this work, we specifically looking at comments and want to understand, would the comments be helpful to explain and detect fake news, and how to model this content and comment relations for explainable fake news detection. So in the real world scenario, news contents and user comments, they are usually inherently related, and they can provide important cues for explanation and detection. So first of all, news sentences, they may contain false information, and some of them, they're very, very, we say, check-worthy for those fact checkers, right? In addition to that, user comments, they have some additional rich information, such as their opinions, some additional evidence that can be very helpful. So in this example, as shown here in the figure, we can see that users discuss different aspects of the news, such as, for example, the first comment is about president does not have the power to give citizenship in the US, which actually directly responds to the false claim on the left side, talking about, the president has granted US citizenship to 2,500 Iranians. So you can see this comment is very, very helpful to explain the news, the false claim. Okay. So to model these relations between the contents and the comments, so we propose a framework called DEFEND. As shown here, it includes four major components. The first one is a news representation learning component. It actually uses a hierarchical attention neural network to model the hierarchical structure in the news document. Second, as I said, comments may contain very useful semantic information. So we encode the comments through this, like we call word level attention network. So after we obtain the representation of sentences and comments separately, we propose a co-attention network to capture the correlations between the sentence and comments. So finally, we can concatenate them together to predict fake news. Okay. In terms of experiments, we first evaluate whether this DEFEND model can detect fake news more effectively by comparing with several state-of-the-art methods as shown in this table. We have these two data sets from the fake news net, and we compare different types of methods. And we can see that in general, those methods modeling these user comments are slightly better than those only modeling the news contents. And also the proposed method can actually perform better than other baselines. Okay. And we also can continue to evaluate the explainability. So what we do is that we first of all evaluate in terms of contents. Basically, we show that the DEFEND model can achieve better performance to capture those check-worthy sentences in a piece of news. This is because that in a news piece, usually not all of the sentences are fake. Actually, it's most likely it's a mix of true and false. So our model can help identify those false sentences out of all of the sentences. And second is in terms of comments. We show that our model can also discover those very explainable and useful comments to better explain the news is fake or not, comparing existing methods. So to quickly summarize this work, we study a new problem of explainable fake news detection. Is first of type of question, first of this type of work. And we also propose a model defend that can identify explainable sentences and also the user comments effectively. And it achieves a high accuracy comparing with this existing model. Okay. So we have shown that social context is very important, but again, usually it's not very kind of practical to get a lot of social context for fake news detection. And we want to understand how can we detect fake news early and with very limited data. So next, I will briefly go through the third work on early fake news detection, which is published at ECML PKDD 2020. So existing research has shown fake news can actually spread farther, faster, and deeper, and even more widely than true news. Okay. So the goal of this paper is really to detect fake news at an early stage with very limited annotated data. So the motivation here is that, since this large scale social media data, they can provide very rich but noisy this user engagements on the news. So we want to answer these two questions. First one is that would the social engagements be helpful to detect fake news early? And how to learn from this, we call weak social supervision for this early fake news detection. So again, this is a real world example. We can see that user engagements usually can provide different sources of information to help us to derive weak social supervision. For example, in this figure, we can see this fake news is about Japanese whaling crew eaten alive by killer whales, 16 dead. Okay, this is a piece of fake news. And you can see on the right side, this a lot of users' posts and comments can provide a lot of opinions and sentiment. For example, the phrase said, "I just don't believe it." This actually expresses a negative opinion, right? And the second one is kind of agree, actually provides a positive opinion. So basically, we can extract the weak supervision from different perspectives, such as sentiment and bias and credibility. Okay, so we propose a model to effectively leverage this weak social supervision from multiple sources, because signals from different sources, actually they are noisy and they can be biased, so the qualities can be different. So we propose to jointly learn the correlation and distinction from this clean label and weak labels using this framework. But basically, the loss function, first of all, is to minimize the prediction error of the clean labels and also the weighted summation of the weak labels from different sources, as shown here. So the key here is to learn a label weighting function. So we use meta learning and to optimize this problem and learn the proper weight for each source of the weak supervision. Okay. So in terms of experiments, we compare this model with several state-of-the-art methods for fake news detection, and we observe that the proposed method can consistently achieve the best performance in terms of early fake news detection on different data sets. And we also show that the proposed model with multiple sources of weak social supervision, they can have better performances than single ones. Okay. So a quick summary, basically in this paper, we study a new problem of early fake news detection with weak social supervision. And the proposed model MWSSS can conjointly model this very little labeled data and also a multi-source of weak label data for early fake news detection. And through experiments, we show that different sources of weak social supervision, they can contain complementary information. So now I have basically introduced how to learn with weak social supervision to detect fake news and disinformation with these three computational tasks to solve the challenges of detection challenge, explainability challenge, and the data challenge. Okay. So next, I will briefly introduce some lessons learned and future research directions. Some lessons learned, first of all, is fake news detection is a difficult task. It is evolving, fake news is evolving with time, and the past may not be directly indicative to the future. Second, data is the key. But in the real world, it's very usually impractical to label data at a very large scale, right? And third, early detection is very important. But we can see that only data-driven approaches usually are very limited. We need to borrow some concepts and theories from other disciplines. So in terms of future research, there's a pressing need for interdisciplinary research. First of all, how to integrate theories from different disciplines such as social science, psychology theories, and so on, to machine learning models, right? So one way is to use this weak social supervision. And second, how can we advance, AI and machine learning techniques can help to combat disinformation. For example, there's some new form of disinformation, such as the deep fakes, these fake videos, and so on. How to deal with these new challenges of fake news, right? And third is beyond the detection of fake news, we really want to focusing on how to do the attribution, meaning to find the sources of the fake news and how to do characterization to understand what's going on during the news spreading process, and how to do mitigation to make sure that there are as few as possible people to be affected by fake news. Okay. So thank you all, and this is some resources. Most of them, they are public available in terms of this research. We have a tutorial, and we have a new data set on fake news for COVID-19, and some other books and monographs. They are all public available to benefit this research community. Thank you very much, and I'm happy to take any questions.